Thank you very much. So today I will be summarizing background evidence for associations between food choices, morbidity, and mortality. And I will present findings from systematic umbrella review frameworks and also present some of the findings from the Food for Healthy Life study. So as you probably many of you know, the globally dietary risk factors are estimated to cause approximately 11 million deaths and about 250 million disability adjusted life years, and cardiovascular diseases, cancers, and metabolic diseases, including diabetes type 2, are among the dominating causes. And just during the last 5 years, more than 250,000 scientific articles has been published on these topics, and this is challenging to navigate for both clinicians, policymakers, and even for researchers. And that is the scene and background for our group to try to better understand the total evidence on food. So just a brief introduction to our group, in addition to myself, also including Professor Antonello Lorenzini from University of Bologna, Øystein Haaland and Kjell Johansson from University of Bergen, Carlos Chelis Morales and from University of Glasgow, and John Malters from University of Newcastle, and Marcus Springman from University of Oxford, and Catherine Livingston at Deakin University, among others. So, I will also briefly say something about what these bricks that I will in short present more about, what they will build into, and these build into these food models, food for healthy life food models. And some of you might have seen our former models presented first in the PLOS Medicine in 2020, and then again or 2022, and then an updated model presented in October last year with UK model using UK Biobank data published in November 2023. Just kind of brief for how these data fit together. So our models use a lot of nutritional evidence feeding into the Food for Healthy Life models, and then these are built on top of morbidity and mortality from the Global Burden of Disease study, and using modeling with Monte Carlo simulations and some assumptions on effect delay and potential overlap. These are then we estimate likely gains or losses for different changes in eating, and also estimating the likely uncertainty levels. So, and one of the important bricks into these models are the meta-analysis. Meta-analysis presenting associations between eating of different food groups, intake of fruits, vegetables, nuts, red meat, processed meat, eggs, dairy, fish, etc., and how these are associated with mortality, cardiovascular diseases, cancers, and other morbidities. And then identifying the most comprehensive and up-to-date meta-analysis is one of the key tasks. And how to do this? So the last few years, we have been working intensively on systematically identifying the best evidence bricks. So conducting umbrella reviews with systematic review approach and meta-analysis approach to summarizing studies on intakes of food groups and how they are associated with all-cause mortality, type 2 diabetes, overweight and obesity, and soon we are also publishing on cardiovascular diseases, cancers, and infectious diseases. So I'll present more on these now. So just in short, the methodological approach to this is built on a systematic search in Embase, mirrored in or Medline, mirrored in Embase and Web of Science and Epistemonics, screening some 1,000 records, identifying 41 meta-analysis on different food groups and their associations to mortality. And when quality assessing these studies, about half of these were of high quality, a fifth of these were of moderate quality, and then the rest of low or critically low quality. And these consisted of cohorts and case control studies, so observational study with follow-ups, and most involved more than 1 million participants, usually with a range of 100 to 250,000 events. In other words, the deaths as the outcomes, and the exposure of interest was the food group. So the intake of fruits, vegetables, nuts, legumes, fish, eggs, etc. And these were either compared with high or low consumption, or in preserving consumptions, alternatively also with nonlinear dose response. And let me quickly summarize what we identified. So we identified meta-analysis for all of these food groups, and there were generally meta-analysis with high or moderate quality for all of these, and summarizing both high consumption compared to low consumption, or preserving consumption. And let me summarize some of the findings. So in short, when summarizing high intakes compared to low intakes, there was a weak trend to increased mortality with higher intakes of added sugars, no clear trends for day intakes of dairy with high versus low intakes, small insignificant trend for eggs, protective association for a high intake of fish, a substantial association to lower mortality for high intakes of fruits, a small positive or an association with high intakes of legumes and lower mortality, and very strong association between high intake of nuts and lower mortality, and the reverse for processed meats and red meats, with more uncertainty for refined grades. Sugar-sweetened beverages was also associated with increased mortality, while vegetables was associated with reduced mortality. Whole grains also as those among those food groups with the lowest mortality for high intakes. In terms of per serving, when the findings were generally similar, with no clear patterns for added sugar diarrhea, an association with our weak association with increased mortality for high intakes of eggs, and inverse for fish, and also protective association for fruits, similar trend for legumes, strong association to reduced mortality for nuts, and association to increased mortality with high intakes of processed meats and red meats, and reduced mortality for vegetable intake and whole grain intake. The evidence for diabetes, which included 67 meta-analyses with over 1 million participants, and many of them with significant heterogeneity. Both a third of these had high quality, and an eighth of these had moderate quality, and then almost half of these had either low or critically low quality. In short, these also had data on associations between all the food groups and their associations to diabetes type 2, and many of them also to metabolic syndrome as a related outcome. Just hide this one. So in terms of the findings, they were relatively parallel. The data showed lower rates of diabetes with high intakes of dairy, and high intakes of fruits, and high intakes of whole grains, and then and higher rates of diabetes with high intakes of processed meats, red meats, and sugar-sweetened beverages. The per serving results were also relatively similar, with particularly strong associations to higher risk of diabetes for high intakes of processed meats and red meats and sugar-sweetened beverages, and the strongest associations to reduced risk of diabetes seen for high intakes of whole grains. In terms of obesity and overweight, we also similarly assessed evidence, and it identified 13 meta-analyses with up to 500,000 participants, and 12 of these were of high quality and 1 of low quality. And these were relatively similar to what we found for diabetes type 2. So in short, the strongest protective associations, in other words, associations between high intakes and low risk of obesity seen for whole grains, legumes, and fruits, and on the other side, the strongest associations to increased risk of obesity seen for high intakes of red meat, sugar sweetened beverages, and processed meats. Similarly, also presented with preserving data. However, for some of the food groups, there were less available data here, but particularly, the protective associations also observed for legumes and whole grains, and then sugar sweetened beverages also coming up high on the increased risk of obesity. So, and in a few months, we are also publishing on the umbrella reviews on cardiovascular diseases, cancers, and infectious diseases. So, and how are these used? So, what are how will these puzzle bricks build into the total evidence? And I can say a little more on that. So, and just to show an example of some of these meta-analysis, for example, one of the meta-analysis on fruits and vegetable intakes and the risk of cardiovascular diseases, cancers, and all-cause mortality. So these present data, both high versus low intakes per serving and non-linear associations between intakes and all-cause mortality, similarly also for cardiovascular diseases and for cancers, and indicating association to reduction in all of these outcomes with high intakes up to about 800 grams per day. And we also, through this umbrella analysis, have identified similar both per serving and nonlinear dose response data for all food groups. So, and through these, that is the building brick building into our models. And as mentioned, this is put on top of a layer of background mortality using data from the Global Burden of Disease study. And then we have several assumptions on how the timing of changing in diets, how these contribute to changes in outcomes, in other words, in reduction in mortality, and in other words, and how that impact on life expectancy. And then we use Monte Carlo simulations using these assumptions and repeat scenarios, and then using that to form uncertainty estimates. We also have assumptions on the degree of overlap, so that in principle, each of these food group intakes, they are adjusted for confounders and likely confounders, including age, sex, but also intakes of alcohol, smoking, physical activity, and many of them are also adjusted for intakes of some other food groups. However, they cannot adjust for all other food groups. That would kind of violate the models. So there can be some residual confounding within the estimates. And by using data from UK Biobank, we have estimated that these residual confounders are likely to be in the range of 12 to 25%. And to be conservative, we then used an estimate of 25% overestimation and reduced and used that in our model adjustments. So and then further we use these models or into these models we feed in different assumptions on how are the dietary patterns in different countries, and then by making different scenarios to how these can be changed, for example, by adhering to dietary guidelines in different countries, such as the new Nordic nutritional recommendations launched 1.5 years ago. We can then use this to this to model the likely gains that different people can have in changing diets. And we also have looked into the evidence from each of the food groups, and then also importantly for the overall changes in diets by kind of summarizing each of the food group changes and the total life expectancy gain, and then weighting by the contribution from each of the food groups. So and in short, our models use are run in an R package, and we use a web application with the use of R Shiny, and this is presented on our webpage, foodforhealthylife.org. So it should be possible for all to could test our models and testing different scenarios. I won't present from our web application models, but in short, that provides the opportunity for people to provide data on how their dietary patterns look like, categorized in eating of food groups currently, and by looking into how they can be changed by in doing on the right side in this new scenario. Then we can compare the differences in the two scenarios, compare the risk differences in terms of all-cause mortality, and also soon in terms of cardiovascular diseases, in terms of cancers, diabetes type 2, and we can provide each with an estimate of the likely gain or loss of different dietary changes. And our models also account for differences in height, weight, activity levels, and sex and age. So to account for differences in energy needs, and for example, such that a young, tall, active male would generally need higher energy intakes and higher food group intakes than small and inactive female. And in short, we have also through these models estimated to how could changes in different age play out in terms of the potential for life expectancy gains, and in general, even at quite advanced age, the potential for substantial gains in life expectancy in reduction of cardiovascular disease should be substantial. As mentioned, we also use data from UK Biobank as a kind of validation approach. So we used a different data source, a different analysis approach to see how what models or what conclusions would come out from using different data sources. And in short, the conclusions were quite similar. The data did not allow for the same degree of detail as our models using all nutritional data from the meta-analysis. However, the patterns were very much the same. And as mentioned, we have also used our models to estimate different potential life expectancy gain potentials in different countries for different age groups, and also by adhering and how different food groups can contribute to this, and that, for example, optimizing intake of whole grains would be one of the most important food group changes, and similarly in reducing the intakes of processed and red meats and added sugars, also as one of those other important changes. A few words on what we are working on and where we are soon to launch updated models. So we are now building in these evidence bricks from the umbrella reviews into updated models which account also for cardiovascular disease risks, for diabetes type 2 risks and cancer, and both as part of the background morbidity, but also in terms of the how the changes in the 10-year risk of each of these disease groups from different dietary changes. So in short, using this framework of combining modeling with systematic umbrella review analysis, we have tried to summarize both data and provide more a framework which should give each a better idea of how different food changes can impact both in terms of life expectancy and disease risks, and that how changes in or increasing intakes of whole grains, nuts, legumes, for example, can impact positively on several of these health outcomes, and similarly in reducing the intakes of red and processed meats and added sugars. So our web application, Food for Healthy Life, provides more details for those interested in looking into different scenarios. Last, I will like to thank the conference organizers for the event, and yeah, thanks.